So let us begin with the problem solving series for electrostatics. So we are beginning with the first problem, and the first problem is stating calculate the ratio of the electrostatic to gravitational interaction forces between two electrons between two protons. At what value of the specific charge q by m of a particle would these forces become equal in their absolute values in the case of interaction of the identical particles? So we need to first of all understand the problem, what exactly it is stating. So the question wants us to analyze electron case first, then we need to discuss about proton, calculating the ratio between the force of electrostatic interaction and gravitational interaction, and then we need to understand a case where we want to equate Fe by Fg and calculate the value of charge mass ratio. So if we get started with the problem, the first case we are discussing about an electron. So we say for electrons, so for electron we can say that the charge is equal to electronic charge E, and the force of interaction Fe can be written as 1 upon 4 pi epsilon naught E square by R square. And the gravitational interaction will give us the result Fg equals G mass of electron, and since both of them are having mass of electron me by R square. So if we calculate the ratio of Fe by Fg, then we can say that R square being equal in both the denominators, we can equate it as E square upon 4 pi epsilon naught G me square. So this is the value in case of electron, and if we substitute the values for the charge of electron and the mass of electron according, and the value of 1 by 4 pi epsilon naught gravitational constant, so we can write it as 1.6 into 10 to the power minus 19 square into 9 into 10 to the power 9, which is the value of 1 upon 4 pi epsilon naught. Then the value of gravitational constant 6.67 10 to the power minus 11, and then the mass of electron, which is 9.1 into 10 to the power minus 31 squared. So if we calculate this value, we are getting a value equal to 4 into 10 to the power 42. Since both of these are forces, so it is going to be a perfect ratio, so there is no unit for this particular parameter which we calculated. Next, the problem is asking us to calculate the same interaction value for proton. So if we discuss about proton, so we say for proton, the value of electrostatic interaction we are writing as Fp. So Fp can be written as 1 upon 4 pi epsilon naught. Now since proton is having same charge as that of electron, we are writing it as E square by R square. Now followed by this, the gravitational interaction Fg can be written as G mass of proton squared by R square. Now over here again, if we calculate the value of the interaction value, that is Fp by Fg, so we will get the equation E square upon 4 pi epsilon naught G mass of proton square. So over here if we substitute the values again, so the electronic charge will be same as equal to protonic charge, 1.6 10 to the power minus 19 squared upon 9 into 10 to the power 9, gravitational constant being 6.67 10 to the power minus 11, and then we put mass of proton 1.67 multiplied by 10 to the power minus 27 kg squared. So on calculation we get this value as 1 into 10 to the power 36. So this is the first answer that we have for proton interaction. This one is for electron interaction. And now the question is asking us that for a general particle, what should be the value of charge mass ratio so that the two forces equate with each other. So at what value of the specific charge q by m of a particle would these forces become equal? So this is what the problem is asking us. So this time we are taking for a general particle, for a general particle. So the question is asking us to equate the value of Fe and Fg and calculate the charge mass interaction value. So we take it as K, that is 1 by 4 pi epsilon naught Q1 Q2 being same by R square, and this is equal to G, mass of the particle m square by R square. So from here, if we calculate the value of charge mass ratio, so we can say Q by m squared can be written as 4 pi epsilon naught G, and since the problem is asking us to calculate charge mass, so we can say Q by m is equal to square root of 4 pi epsilon naught G, when the interaction of both the forces will balance each other. And if we substitute the values, we can write it as 6.67 into 10 to the power minus 11, and 4 pi epsilon naught can be written as 1 by 9 into 10 to the power 9 square root of this value, and it is giving us 0.86 times 10 to the power minus 11, minus 10, and this value is in coulomb and kg, so coulomb per kg. So this is the answer for the value when the forces balance each other, when the general particles interact with each other. So these were the three aspects that the problem was asking us to calculate: the value of Fe by Fg in case of electron, then again for proton, and then for a general particle the value of charge mass ratio when the two forces of interaction balances with each other.